Good afternoon, and welcome to the Society of Wetland Scientists' fifth webinar of 2021 entitled Assessing Functions of Missouri Bottomlands, Laying the Groundwork for Wetland Conservation, which will be presented by Frank Nelson. My name is Jody Murray Burns, and I'm pleased to moderate this webinar and share an SWS e-learning experience during a time when many of us are looking for virtual opportunities to stay engaged. This webinar is one way to stay connected to the wetland community during the global pandemic, and we hope everyone is doing well. For those of us who may not be as familiar with our SWS webinar series, our monthly webinars are usually held on the third Thursday of the month at 1 p.m. Eastern. As you can see on this listing of our upcoming webinars, we have both a SWS webinar series in English and a quarterly Spanish webinar, both of which are open to members and non-members alike. Our recorded webinars are also posted to YouTube for free viewing, and we currently have an amazing library of over 60 different webinars on various wetland topics. Another expansion of the webinar program is the development of wetland interviews. Make sure to keep those on your radar. We are proud to recognize our 2021 SWS webinar series sponsors. First up, we have the Witten Group, which is a natural resource consulting firm that balances regulatory compliance with sound ecological management. And HDR, who specializes in engineering, architecture, environmental, and construction services, creating an unshakable foundation for progress with their multidisciplinary teams of scientists, economists, builders, analysts, and artists. You can find their information at the websites listed above. Next, we'd like to recognize In Situ. In Situ's monitoring equipment and software works together to make it easier and more cost-effective to collect, access, and manage data on water levels, water quality, water flow, and more. Delta Land Services, which is an environmental restoration, mitigation, and land management company, provides complete and comprehensive mitigation services to both private and public industry throughout the Gulf Coast region. And lastly, WildNote, which is a field data collection app for environmental professionals that streamlines the process of collecting, managing, and reporting environmental data so you can work smarter, not harder. Please visit, like, and follow our 2021 SWS webinar sponsors. Since January 2018, the SWS Webinar Series Committee has worked to have our SWS webinars pre-approved by the SWS Professional Certification Program to count for continuing education credits that can be applied to your professional wetland scientist certification or renewal. The webinar today has been pre-approved for SWS PCP educational credit. Participation certificates for watching the webinar in its entirety are available through an automated process. You will receive an email from Susanna Hagendorn of the SWS National Office about 1 day after the webinar. Check your spam or junk folder if you don't see it. These certificates are free to SWS members. Participation certificates are also available for those who watch webinar recordings, which can be found on our events calendar page or our YouTube channel, complete with multilingual captions. Before we get started, let's go over a few housekeeping tips. First, the general format for today's webinar will be a 45-minute presentation by our speaker, followed by approximately 15 minutes of questions and answers. Secondly, all attendees will be muted for the duration of the webinar, and all questions by the attendees must be asked with the Q&A button shown here, not by using the chat button, which is reserved for technical difficulties and monitored by the SWS staff. At any time during the presentation, you can type your questions into the Q&A window. Participants may upvote questions in the Q&A that they would like to be answered earlier. Lastly, a survey will be sent to you via email from Zoom 1 day after the webinar. Please complete the survey to give us feedback about today's webinar and the SWS Webinar Series program. We are constantly striving to improve what we offer to you in our webinar series. Additionally, please indicate if you're interested in giving a future SWS webinar. So it is my distinct pleasure to introduce our speaker today. Frank Nelson has a BA in biology from William Jewell College and an MS in wildlife and fisheries sciences from the University of Missouri Columbia, where he studied wetland systems and the breeding ecology of least bitterns. Over the last 17 years, Frank has worked for the Missouri Department of Conservation as a wetland ecologist, where his focus has been applying research and technology to enhance wetland management, monitoring, and restoration. This has included using elevational data to inform water management decisions and to help guide wetland renovations on conservation areas like Duck Creek and Shell Osage. During the last few years, Frank has led a group of state and federal partners to develop a geospatial dataset for Missouri's 10.4 million acres of bottomland habitat. This project establishes two baselines, the historic and current extent, as a means to assess the changes in the capacity for 6 ecological functions. This data set will serve as a valuable tool for strategic planning among partners focused on wetland conservation in Missouri. Just a few fun facts about Frank. One of his favorite things about wetlands is that every time you walk into a wetland, even if it is the same one you've been to for years, you'll likely be able to see and experience something new and different. He's always excited to learn new things, dabbles in art designing fighter jet paint schemes, and 20 years ago this year, he had a least bittern ice sculpture at his wedding reception, a nod to his master's research work at the time. With that, I will hand over control to Frank. Welcome, Frank.
Thank you. I appreciate that. Hopefully those are a couple fun little tidbits. And I appreciate the opportunity to talk to you all today about what work we've done assessing functions in Missouri's bottomlands. And so I'm going to focus a little bit about considering the changes in terms of our shock absorption capacity here in Missouri. And I just want to say thank you to the many partners that participated in this project, as well as my co-authors at MDC, as well as MORAB. So to start things off, I'm going to give you a little bit of context of Missouri's bottomlands and our wetlands, and then also our approach to establishing an ecological framework. And then I'll get into those examples of shock absorption. So when you're thinking about Missouri, our wetlands are a little bit different than, say, places to the north or the south, and the fact that ours are primarily driven by riverine processes, as opposed to, say, glacial or coastal. And so our assessment needed to also reflect our settings and those formative processes. Also within Missouri, we have different ecological regions, and so the soils, geology, and hydrology vary. And they've been shaped, the floodplains have been shaped with, say, glaciation in the northern extent of Missouri. And those glacial meltwaters really impacted southeast Missouri and that Mississippi alluvial valley. When we think about the Ozark Highlands, it's how water interacted with the geologic uplift and weathering of that karst geology. And to the west, we have softer, more weathered rock in a drier climate. And so the ecology of those systems are also somewhat different. When we think about the hydrology itself being a riverine system, overland flow is the key driver of most of our wetlands. However, groundwater discharge also impacts those wetlands in our Ozarks, such as the seeps and the springs and the fins. And then also even precipitation really drives the hydrology of, say, our sinkhole ponds. And so having this context is important when we're looking and trying to think about ecological functions. So when we think about our floodplains, these are relatively narrow strips of ground, flat and fertile, and therefore there's been multiple streams of income taking advantage of these conditions. And so because these are scalable, essentially, we've been able to overpower our natural features with engineering. And so today our landscape looks, it's quite modified with a variety of uses. Drainage has definitely impacted our wetlands with over 6,000 miles just in southeast Missouri. It's quite an intricate network of drainage throughout that part of the state in particular. If we think about our big rivers also, there's been altered river flows with dams and flow modification. There's also been, of course, the conversion of land and development. If we just think about forest cover, and whether it was nationally or even here in Missouri, we've lost quite a bit of the natural forest that used to occur. And then also just the amount of infrastructure and development, the amount of roads that have increased over time across the United States. It's also the trend that holds in Missouri. And then also, if we look at the height and size of our levee systems, say along the lower Mississippi River, our levees just keep getting bigger. And then also what we don't always see, but has been increasing over time, is the increase in nutrients, whether it's phosphorus or nitrogen. So all these things, not only have they impacted the amount of wetlands in Missouri, but also the function has been drastically reduced over time. And so, you know, this mid-latitude state with riverine systems, these small floodplains are much more impacted than, say, some of the other systems. And if we look at wetland functional assessments elsewhere in the country, there's the HGM guidebooks with U.S. Army Corps of Engineers, and then also Ralph Tyner's work with NWI+. And what we see is we don't have a good example for Missouri that we could use. And so, but we definitely use these as a model to think about these questions of ecological services. In Missouri, we've been doing planning over the last 40 years, and in the last few years, we've actually tried to re-envision what we mean about wetland conservation, where do we want to go? And so that's through this wetland planning initiative, which was really the first step in this effort. And it was a unique effort in the fact that it was multidiscipline, multidivisional within the department, just trying to get everybody's input and from different disciplines. And what we laid out was, you know, something different. Instead of just thinking about critters, we realized that our ecological goals must reflect and interact with social goals. And so that's kind of a big change in the way I think, as me as a professional, has been thinking. But before we get to the critters and the public use, we really need to think about those ecological processes, the landscape setting that feed into those wetland habitats and dynamics. And that's where, with this wetland planning initiative, we're kind of laying out our understanding of the system, if you will, of functioning watersheds and healthy wetlands, and assessing what did we have in the past and what do we have currently. And so this is really the first step, and this, along with two other assessments, social assessment and then a life history assessment, is really laying the foundation for our wetland planning initiative. And so we reached out to our partners and said, hey, would you like to join us in this effort? And you know, multiple agencies agreed that we definitely need a better historical wetland baseline, as well as a current extent of wetlands in the state. And if we could tie it to ecological functions and services, that would be great. And so we kicked off this effort by trying to figure out, okay, we don't have a good up-to-date NWI, so what's the starting point? And another example in Indiana, which is another mid-latitude riverine system, used soils data and found, you know, that's a pretty good proxy across large landscapes, especially in unaltered extents. We looked for examples here in Missouri as well, and Rob Jacobson has the Missouri River Land Capability Potential Index that also uses soils information. And so that, you know, this would be a good predictor of vegetation. In the last few years also, Missouri has worked with NRCS on the Missouri Ecological Classification System. This is using statewide soils, and so we don't have any data gaps that we might have with, say, Rob's work or elsewhere. But basically, using the soils map, we divine the past ecological communities based upon geolandforms, soil properties, and vegetation. And so this is essentially our prediction of where different communities should exist, and did exist historically. And it works out pretty well if you look at our bottomland habitats. If you think about how water shaped the geolandforms, whether it was the upland drainage ways, those historic terraces, or even the high and low aspects of the floodplain, water definitely had an impact in shaping that topography. If we think about vegetation and how that shapes the soil processes with prairies and that rich organic matter versus, say, the soils of a forested system. And then hydrology also plays an influence on soil stratigraphy, where the sandier soils, those coarse materials drop out versus the locations with the finer sediments like silt or clays. And so knowing that we had a good data set to begin with, then it was like, okay, so where do we draw the lines in terms of wetlands? Because that's not always an easy thing to do. And do we use the ecological definitions or a jurisdictional definition? And what we ended up doing was kind of lumping them hydric and non-hydric together and just looking at our bottomlands in general. And the alluvial sediments was basically where we drew the line. And it captures most of Missouri's wetland communities, along with some adjacent upland habitats. And so this totals about 10 million acres. If we look at just the wettest habitats, that's more like 6 million acres historically. And we also divvied up the state with regional boundaries. And this too was a bit of a hybrid approach where we looked at terrestrial communities, but then also the aquatic boundaries of our watersheds. And so we came up with 7 ecological regions, and you can see kind of how I split the state up previously. This is similar with some additional subregions. And so this was kind of our ecological sideboards and foundation where we wanted to start with our partners. And so then we started having this discussion of, well, which ecosystems do we focus on? What were the key drivers or processes? And so we identified streamflow maintenance, flood damage reduction, denitrification, phosphorus retention, and carbon sequestration, and developed a historic ranking based upon that ecological site description. What we don't have in terms of the past, because of all the alterations to our floodplains, but felt that it was very important to establish a current extent, was stream-based stabilization. And then there's also opportunities to add more ecological services at a later date. So we can kind of build off this initial framework. We dug into the literature for both references for past conditions as present extent. And we presented our results and received partner input several times over the course of 3 years. And we developed our metrics and our layers and shared that with experts and received input from them and tweaked our models and came up with our final product. And so we have a gradient across these ecological functions. And so we wanted, depending upon where you are in the landscape, it could be high or low, depending upon which function you're looking at. And that really forces the question, what is your objective for this parcel, this habitat that you're standing on? And from that historic ranking, we then adjusted that to get our current ranking. And so our historic ranking was the reference point, essentially. And looking at the key drivers and the alterations, we then adjusted those. So here, this example is looking at how land cover would influence our current ranking. And it could also be bumped up or down based upon the potential for sediment traps with that land cover, or whether or not they are on protected lands. And so when we look at our 5 main ecological functions, flood damage reduction was impacted by levees and channelization. Streamflow maintenance was also influenced by wetland drainage. If we think about our land use practices, clearing and tillage, that decreases our capacity for carbon sequestration. Because of the addition of fertilizers and runoff, we have more nitrogen in some instances that to be denitrified. And then also same thing with phosphorus retention. There's an increased capacity in some places. And so starting with that historic framework, when we divvy up the landscape, we have what we have today here in Missouri as a much fragmented and complicated landscape. But with our workflow, we felt like this was a good way and a defensible way to lay out our understanding of the processes. And it's an opportunity to kind of figure out, okay, and set objectives. Where do we need to work based upon our understanding? And so we have this report we finished in 2019, and I'm going to highlight a couple of our examples of kind of essentially where and what is the quality and what were the drivers that influenced our past and present conditions. And so here's just some statewide trends of, let's say, flood damage reduction. The first columns, the crosshatched, is the historic extent with the solid columns being the current extent or potential. And you see flood damage reduction has been reduced, which is what we've seen. If you think about the amount of habitat we've lost, function has also been reduced. Denitrification has a little bump, but most of it has been reduced. Carbon sequestration follows this trend in terms of reduction of capacity. Streamflow maintenance also shares this downward trend. And then phosphorus retention has increased a little bit in some areas because it's more available today than it was historically, and then it's decreased elsewhere. And so, Missouri's a water-rich state, and which is a blessing and a curse in the fact that we have droughts and we also have floods. But when we think about wetlands, these really, and I'm going to highlight both flood damage reduction and streamflow maintenance, they're on two ends of the spectrum in terms of where you can expect the wetlands to occur that really contribute to these ecological functions. And so they really do perform as shock absorbers when we have these extreme events. So first, I'm going to look at streamflow maintenance. And to get into the major drivers, headwater locations is essentially where, if you add up all the headwater contributions, that's what's driving the flow in the larger streams downstream. Discharge wetlands are a major contributor here. So looking at our upland drainage ways, our seeps, fens, and springs, and those locations on the foot slopes are really critical in contributing to further downstream. Secondly, even in this karst area, those areas connected to the aquifer, so our sinkholes, are also important in this contribution. Secondarily is our larger floodplains, more porous soils where we have infiltration and bank storage. It also contributes to streamflow maintenance, but to a lesser degree. And so if you look at a profile of, say, the hills versus the bottoms, landscape position and soil drainage, this is how we ranked the historic extent. And so if looking at our map view, essentially you'll see higher up in the watershed, you had the higher capacity. As you move down into more of the medium capacity. And then our big floodplains is ranked low because of the lesser degree. Now looking kind of at the results and regional differences, if we look north of the Missouri River in the glaciated hills, you can see that there is a pretty good high and moderate capacity for streamflow maintenance. But when you compare that with, say, the Ozarks south of the Missouri River, you can see that the amount of headwater streams there really does increase that high capacity for streamflow maintenance. And if you've ever been in the Ozarks, you'll know that it's a really neat area in terms of the springs and streams. And this is due to that geology, that leaky lithology, where water is kind of running through the rocks and poking out of the ground everywhere. And so this is kind of as a reflection of that. If we look at, say, the Missouri River floodplain as our big river example, you can see that it does contribute, some of those places contribute to recharge, but not to the same degree that you would find higher up in the trips. Now, the way we adjusted our ranking was thinking about the reduced infiltration and increased runoff. So if you're thinking about, the root mass that's there, that would have been there historically, and how that contributes to infiltration versus today's landscape with agriculture and the amount of runoff that is contributed, we use land cover as this metric to adjust our rankings. And then also we looked at the density of roads as well as the density of channelized streams and ditches as a way to account for the hydrologic disturbance and impairment that is occurring. And so this is the historic ranking potential that we had based upon our metrics. And then when you throw in the infiltration and hydrologic disturbance, this is kind of adjusting up or down for streamflow maintenance. And then the overlaying current ranking potential that results from this adjustment. And so when we look at regionally, how these different things lay out, you've already seen the historic potential, but we kind of still have those same trends when we look at the current potential, with, say, the Ozarks having a greater capacity than, say, the Big River floodplains. And so so this is our assessment. The next step really is kind of to derive our objectives. And so when we're considering these objectives for different parts of the state, essentially, in the Ozarks, essentially, we may be thinking about how can we protect these areas that contribute to our karst fens? How can we, so that we can maintain this capacity for streamflow maintenance, since it's still pretty good. And so looking at the locations that are just adjacent or upslope of our fens is probably something we should target. If we go to, say, north central Missouri, where we've lost our capacity for infiltration, perhaps we need to think about increasing our groundwater infiltration. And by doing that through riparian corridors or cover crops is a way that we can regain some capacity within this specific landscape of Missouri. And so, you know, our objectives and strategies across watersheds are going to vary based upon the stressors and the capacity that are there. And our different wetlands and landscape positions are going to play different roles. Our slope wetlands, springs, and fens and headwaters really do contribute to having this buffer to the threat of drought. Now I'm going to switch gears into flood damage reduction as another example. We're going from the headwaters now to our big river systems. And if we think about reducing flood damage reduction, a lot of it is allowing space for water to spread out and slow down. So lateral connectivity is really important. Slowing the flow, so having vegetation like trees to reduce the velocities is important. For those areas that are not adjacent to rivers and streams, storing water is one of the other drivers, as well as slowing that runoff and increasing that infiltration. So when we look at our profile, essentially, and how we ranked it based upon flood frequency, cover type, and landscape position, this is kind of a general example of our ranking system. And so if you think about the glaciated hills, these are a much wider bottomlands that also have vegetation. And so those things contributed to having a much higher ranking in, say, northern Missouri when we're thinking about flood damage reduction. If we go south of the Missouri River line, essentially you have these narrower valleys that we saw with streamflow maintenance, but they're still forested, and so they still can slow down water when water gets up and out, but there's a reduced capacity. When we think about, say, the Missouri River floodplain or even the Mississippi River floodplain and the alluvial valley, this is the broadest, has the most space to store floodwater. And we're also quite seasonally inundated in the past, and also had the vegetation to slow the water down. And so when we were looking at alterations and metrics, in our big river bottomlands like the Mississippi and the Missouri, our federal flood protection levee layer was really critical in how we ranked the current extent. And so you can see here an example of, say, the Batcher land versus the locations that were protected behind the federal levee. In other places where we didn't have the federal levees, we looked at the percent catchment that was covered by conservation programs, whether it was public land or WRE. Basically, you know, WRE is these locations that have been agricultural land that is flood frequently, that has been enrolled into this conservation program to allow these places to go back into to wetlands. And so through this manner, we were able to highlight locations that allow floodwaters to spread out more readily. And then land cover, you know, thinking about places that are forested, and then our big river systems, greater than 300-foot riparian corridor, which when we, in the 1993 flood, saw that these locations were much more protected than locations with less riparian corridor. And so here's an example of the extent with riparian corridors in the Missouri River bottoms. And so once again, here's an example of our historic ranking process and overlaying that alterations and decreased capacity based upon our metrics. And then as a result, then our current ranking potential. So kind of diving back into the regional examples, once again, this is a kind of a mirror image of what we saw before, with Big River floodplain having the most capacity historically, and with that reduction on the Ozark Hills. But the current extent, there's a lot of ground that's risk to flood damage. And unfortunately, we've seen that in the last few years. In 2019, you might remember, we just got done with this project and we had an immediate application to test our assumptions and also kind of contrast some differences in river management. I was able to take some near real-time flood mapping from NASA's satellites and provided a downloadable flood coverage. And so we overlaid that with our bottomland layer on the current extent and clipped those areas impacted by the 2019 flood extent and kind of see what was underneath. What did we say in terms of the potential for flood damages were? And if we looked up in Northwest Missouri, in the upper Missouri River floodplain, we found that historically these acres that were inundated in 2019 were ranked pretty high and exceptional. But now, there's only a few isolated locations along the river that are in conservation area or battery ground. And so most of the acres were at risk of flood damage. And so behind those levees, there's a lot of potential for damage if levees are about to break. And that's what we saw, unfortunately. If we switch gears and go down to Southeast Missouri, there's a slightly different story. Although ag is widespread, there's room along the levees for floodways that allow water to back up every now and then and provide that relief, as opposed to letting the river pick where the holes are going to be. And so historically, these acres, once again, were ranked exceptional. But today, the capacity is still there. Even though there's farm ground, there's still that capacity to absorb that water. And because of that, there were less damages because there's more space for water to spread out. And so even though flying over that region, you can definitely see it was wall-to-wall water, the amount of damage that was there compared to elsewhere in the state was minimal. And so when we're thinking about the objectives, say, of flood damage reduction in these different parts of the state, they may be different because of some of the drivers that contribute to flood damage reduction. So in Northwest Missouri, we may think about opportunities to increase the lateral connectivity so that there is more space. Where in Southeast Missouri, we have space, but there's still places where we could probably reduce some of the damages just by reducing the flow velocity. So where there's locations to restore bottomland forest or expand upon existing blocks of forest in these established floodways and backwaters could also be beneficial. So, the objectives may be slightly different based upon how these regions interact with the surrounding environment. And so just kind of thinking about the drivers and the shortcomings based upon region. So hopefully, it's the old adage, location has been able to kind of hit that home with just these two examples of flood damage reduction and streamflow maintenance. And also kind of hopefully this shows you how we were kind of laying the groundwork and assessing our current conditions, which should help point towards how we should set objectives as we move forward when we're thinking about landscape position and system drivers. This provided a much needed baseline we got some great input from our partners, and it's a starting place for us to start to craft a story to generate support for these different values and ecological services that wetlands provide. It's also a starting point. We established this relative scale, but now, we can go further and test these assumptions and quantify to what degree is, say, carbon being sequestered, to what degree is denitrification occurring in these different locations. And so this is hopefully just the start. And it's a rich data set that we can use in the future, hopefully to set objectives and also collaborate amongst other agencies. That it's not just MDC that can use this information. Hopefully we can all work with it and to help advance wetland conservation in the future. And, it's kind of specifically modeled to adjust for Missouri's landscape and the fact that we are an altered riverine system. And so trying to take that into account as well. So I appreciate the opportunity to talk today, and I'd be happy to answer any questions.
Thank you, Frank, for that very interesting presentation about assessing functions of Missouri wetlands. Let's get to the Q&A. And again, I'll be posing your questions and maybe a few of my own that I have received through the Q&A button to the presenter. The most popular questions that have been upvoted to the top will be read first. And if you forgot to ask a question or have to leave before the Q&A is over, we can share Frank's email address with you. All right, let's get started. Our first question is, has this project helped you identify any future geospatial data needs, Frank?
Yes, that's a good one, because it definitely did underscore the need for an update for Missouri's National Wetland Inventory. That was just a big hole that we were able to kind of accommodate. However, it's kind of the next step. We really do. It's been since the late 80s that we have a current layer, but since then we have WRE, so that's not integrated in the current extent of NWI. And so to move forward, we really need to kind of figure out how to address that, as well as updating our NHD layer, the National Hydrography layer. Those two things really influence how we as agencies, as well as individuals, can account for and plan across a broad, the scale of the state, and even locally, where these resources are. And so that's something that we were able to overcome slightly with this project, but definitely showed a light on future work that needs to be done in the state.
Good, thank you. I have a little bit of time here. If anyone has any questions, go ahead and type them into the question and answer window or box. I'm not seeing anything right now. Please put your questions for Frank in the Q&A pane. Well, we may not have, okay, here's one. All right, here we go. Now that you have a baseline and a procedure, have there been any areas prioritized for restoration?
Not yet. That's one of our next steps, is essentially kind of exactly what I kind of showed, is to kind of dive into the data a bit further to make these regional objectives, to kind of begin to try to identify places. And so it wouldn't necessarily, it would guide restoration for different functions. And so I would hope that in the future it would. For example, that example of, say, the karst fins, that would show places that need to be protected around our known fins to reduce the streamflow maintenance or the degradation of streamflow maintenance. And so that's what I'm kind of hoping is, as we kind of work through things, that we can look regionally at where are the biggest opportunities, essentially what's the biggest decreases that we have some ground to cover. And then maybe there could be a couple things where, like with the fins, where we just want to maintain or like northern Missouri, where it makes sense for a couple different ecological functions to say increase the amount of riparian corridor or that sort of thing. So I'm hoping those discussions come around.
Okay. Our next question comes from Tim Phobes. The Army Corps Kansas City District is in the early phases of evaluating the Missouri River Basin flood control. This work you've done would be good for your team to sync up with them. Have you been talking to the Corps about the results of this work?
Yes, absolutely. They were actually participants as we developed this project. And then also, as I was wrapping up, actually, there was an annual Corps meeting. And so I was able to present that to the regulators and planners. And so, yeah, they're definitely aware of it. And hopefully, yeah, they'll hopefully be tapping into this resource as well.
Okay, our next question comes from Ricky Wilson. Are there any other functions that you anticipate would be added for evaluation in the future?
Yeah, if you look at Ralph Tyner's work with the NWI Plus, there's a wide range, and they're fairly similar, but they do vary. And I know several states have added functions over the years. Pollination is one that we kind of considered. I think also contaminants, even though that's the earlier ones, water quality was fairly broad. And that was actually one of the things that we split out was phosphorus retention versus denitrification. And so that was a modification as we talked about it. Well, those nutrients react differently. And so we split that out, but I could also see where if we want to look at, say, reducing contaminants, whether it's lead or mercury, is something we could add at a later date too. So it kind of depends on the partners and what our different needs are. We kind of hit the big list, the main ones, but there's definitely additional services that we could add at a later date. And so, yeah, I think we've got the framework set up, and it'd be a matter of identifying those and kind of cranking them out.
The next question, it says, depending on the functions that are prioritized by each stakeholder group, how will you evaluate balancing function restoration, such as flood protection, versus less understood carbon storage?
Yeah, that's a good question, because, and really with carbon storage, that kind of information is advancing as we speak. It's something that I quite honestly didn't have much of a clue 10 years ago. And so trying to put this together and establishing that baseline and thinking about carbon in a riverine system as opposed to, say, more of a peatland system or a coastal system. Yeah, there is a lot of work that needs to be done. And in some instances, I think there is overlap where if you're quite honestly, with flood damage reduction, you are capturing sediment and you are establishing riparian corridors. And so that in itself is contributing to carbon sequestration. So they're not always divergent, and there's opportunities, I think, for overlap, especially with those two. So I think, and that's something we need to be thinking about, because there's certain locations across the state, quite honestly, where there's very minimal flood storage capacity, and what storage capacity has been there, carbon sequestration, the buildup of sediment has occurred, and so we need to think about places that need perhaps more flood damage reduction because the carbon sequestration actually has increased over time.
All right. Are there any other questions out there? We don't have any in our panel right now on the window.
We do have a question in the chat, Jody.
Oh, okay. Let's see. All right. Shane was asking, are the results or maps available for the public yet?
I do not. That's something that I've been meaning to work on, and I would love to get this data up and have a map story where you can kind of search it and look at the data and the various rankings. I do not have that up yet. But if you'd like to have a copy of our final report, I'd be happy to provide that.
All right, can you, we don't have your email address. I know you were wanting to share that whenever we were doing the practice for this. Can you type that into the question and answer, and then Shane can get that from you if you want to share those results with him. Just another minute for any other questions if someone's typing away furiously. And you'll see Frank put his email address in for any who think of a question later after you think about that.
And I really appreciate the opportunity to highlight this work and all the thought and work that our partners contributed with this. So appreciate it.
Well, we appreciate you taking your time out of your busy schedule to share your insights and expertise with the wetland community of SWS, and we just really can't thank you enough. I think we'll move on to our closing announcements. Before we sign off, we wanted to mention about the upcoming SWS webinars that we have planned. Our next English SWS webinar will be held on May 20th, 2021, and will be presented by Matt Stallman, who will be presenting the work on the Bodark restoration site in Texas. Our next Spanish SWS webinar will be held on June 23rd and will be presented by Celeste Franceschina, speaking about macrophytes and invertebrate herbivores in subtropical wetlands. As a reminder, all the Spanish webinars are offered free of charge to members and non-members alike. And finally, be sure to subscribe or follow SWS social media channels like Facebook and LinkedIn to keep informed about the Society. If you are not a member, please check out our webpage at sws.org and find out how to become one to get all the benefits of membership in SWS. We also have a YouTube channel where our webinars are posted 3 months after their original broadcast with multilingual subtitles. And newly added over the past year are our wetland interviews, 2 in English and 3 in Spanish, which are posted to our YouTube page. You can quickly find links to those on the SWS website under the Resources tab by selecting Wetland Interviews. If you are Spanish speaking, be certain to subscribe to the Latin American and Caribbean Regions Facebook page at the link listed here. Thanks again to today's presenter, to our webinar sponsors, and to you, our audience, for participating today. Everyone have a great day and stay well.